Welcome back. Now it's week 12, and we're going to continue our discussion. We ended up last time, the last thing we talked about was fuel trim when it came to our different diagnostics. If you watch the lab video, you'll see that I did quite a lengthy demo on fuel trim and what happens when you let unmetered air in, what happens to the fuel trim. What happens if it gets too carried away, or if you create a problem with something like the mass airflow sensor where it basically stops paying attention and fuel trim stops really happening. So now we're going to move on. The next item on this slide was fuel pressure. So let me bring those slides back up and we can talk about that. So let me bring the slides back up again. Turn me off here and we'll share Blackboard with you. Alrighty, so here we have Blackboard. We're going to go to courses as we usually do and pick, did I just pick the top one? You'll only have one AU-264. And where we are is under lessons. And way down at the bottom is module 3. And here are our slides. So this is what we were working on. Open that up. And drivability diagnosis. So we had gone through common drivability symptoms. We talked about what can go wrong basically with the engine, the way the engine runs. Talked about a diagnostic routine. And then we started talking about individual tests that we could do. And so there's a list here, you know, fuel trim, fuel pressure, vacuum, compression, cylinder leakage, timing advance, cylinder balance, injector balance. And I tried to demonstrate some of those in the lab videos, that which I can. And as we know, not being in the shop, some of these are a little more difficult than others to do. Fortunately, earlier in the semester, we went through compression and cylinder leakage, and some of us saw cylinder balance. We didn't really get to do injector balance, but it's possible you did that in fuel and emissions. I'm not really sure. I haven't talked to the fuel and emissions teacher about that so far. We saw some vacuum testing in the last week we were there. We did a little back pressure test, I think, exhaust back pressure. So this is not a complete list, but these are the things I want to go through. And we just did fuel trim last week. And the thing about fuel trim, you know, that we talked about, let me go back to here, is just as a reminder, it's an indication of how much the computer is having to correct for something that's a little bit off with the engine, or possibly a lot off. So if it's just a small little thing, tiny little vacuum leak, slightly low fuel pressure, something like that, fuel trim can compensate and put the air-fuel ratio right where it's supposed to be, and everything's good. If the problem gets too big, then the fuel trim cannot compensate, and that's when we see a diagnostic trouble code for a too lean condition or a too rich condition. And then the other thing you saw last lab video is when I pulled the mass airflow sensor, the hose off of it, the computer actually knew that there was a mass airflow sensor problem. It saw there was nothing, or not even a slightly realistic number coming from that sensor. So it chose to ignore that, and it chose not to use that to into the air fuel calculation. And so our fuel trim numbers didn't even move. They were still very small single digits because the car was using other sensors to calculate the correct fuel delivery. All right, so if we move on to fuel pressure testing, right? So, whoops, fuel pressure testing. So there's two things that we're going to test here. We're going to test the actual pressure that the fuel pump and fuel pressure regulator combined, what they are supplying to the fuel rail. And the second thing we're going to test is when we shut the key off, when we park the car, is the fuel rail maintaining some pressure for the next startup? So why would we do this test? Well, if we have a no start, maybe we're missing spark, maybe we're missing compression, maybe we're missing fuel. So if we've eliminated spark, probably the second easiest thing is to make sure we have some fuel pressure. On a lot of vehicles, there is a fuel pressure test port right on the rail. You can screw a gauge on. It's no harder than checking your tire pressure. Other vehicles have not included the fuel pressure test port, and so we can't just screw a gauge on. We have to somehow tee into the line. That can be a little more challenging. You need a lot more adapters and things like that. Because of all the different type of quick connect fittings that are on fuel rails and fuel lines and fuel filters, sometimes you have to almost make something up. So we'll assume that we have managed to configure a fuel pressure gauge to measure the fuel pressure on your vehicle. So one thing you should know, when you turn the key on with the engine off, there is a 2-second prime that the fuel pump does. So the computer kicks the fuel pump on for 2 seconds, and this causes the pressure in the fuel rail to go up. So the first step here, it says key on, engine off, cycle several times. What we're trying to do is we're running that 2-second prime more than once. The first time we may not get full pressure. So let's take a 50 psi specification. Let's say 50 is what our fuel pressure is supposed to be, key on, engine off. The first time you turn the key on, it might only go up to 30 or 40. It might take 2 or 3 cycles of the key, but at some point it's going to stop increasing, and that's going to be, your max fuel pressure. That's what you're going to see right there. So, key on, engine off, fuel pressure spec, let's say it's 50. You're going to compare to your specification, see if you have enough fuel pressure without the engine running. Now, most of the time when you start an engine, the fuel pressure will actually go down when the engine's running at idle. So there are various ways that this is done. The early original were a manifold vacuum fed to a fuel pressure regulator. At idle, vacuum is high. That would pull against a spring that would keep the fuel pressure down low. And then as you accelerate and the engine vacuum drops, so if you stomp on the accelerator, you know that engine vacuum can go almost away. It can almost go to atmospheric. That allows, the vacuum goes away from the pressure regulator, allows the spring to push harder and causes the fuel pressure regulator to hold a higher level of fuel pressure. So on idle, you might have, 30 or 35 psi. Stomp on the accelerator, it might go up to 50. And I'm just pulling these numbers out. So don't go by those. Actually, look up the specs for the vehicle you're working on. So you're probably going to have a key on, engine off spec, and you might possibly have engine running at idle spec. And those are the two you want to compare. Keep in mind, if we have a gasoline direct injected engine, then there's really 2 fuel pressures. There's the electric pump in the tank. Some people call it a lift pump. This just supplies fuel to the high pressure pump that's going to be up on the engine, probably driven off the camshaft. So you're not really seeing what pressure is available to the injectors on a gasoline direct inject engine. You're just making sure that your electric pump is working correctly. Most GDI engines, I would say, you can look at fuel pressure, the high pressure side, on a scan tool. It's dangerously high pressure, so you need to be careful if you're working around the high pressure side of the high pressure pump. So right now we're just talking about port fuel injection. We're talking 50, 60 psi, not super dangerous. Obviously, fuel is very flammable, so if you're working around a hot engine, you need to be cautious not to spill fuel all over a hot exhaust manifold and start your car on fire. So now we've done a regular fuel pressure test, key on, engine off, engine running. We like the readings we've gotten. What do we do next? So if you look at the symptoms on the bottom, no start, hard start, the ones in red, lack of power, surging, excessive fuel trim corrections. Let's talk about what could cause all of these things, all right? So no start, obviously, if our fuel pressure is significantly too low, the engine's not going to start. So, completely plugged fuel filter, bad fuel pump, a hole in the fuel line, something like that. Serious fuel pressure problem. We're going to have a no start. Let's skip over hard start for a minute. Lack of power. If your fuel pressure is low, enough to start the vehicle, but not enough to supply sufficient pressure for conditions where a lot of power is needed, that could be a fuel pressure issue. So it's going to be kind of hard to, I can't really draw very well, but this way. But back when I was in the dealer, station wagons were still a thing, with a big family truckster. And we had a big Mercury 9-passenger station wagon. That was before SUVs came around. And this vehicle, it ran fine until you tried to go fast. As soon as you tried to go fast and it needed all that extra fuel to do it, it just wouldn't do it. At first, I thought maybe we had a plug catalytic converter because we have talked about that. But that wasn't the problem. The problem was there was actually a leak inside the fuel tank. The high pressure line coming out of the pump was cracked between the pump and the outlet of the tank. So a lot of the fuel that was coming out of the pump was just coming out of the pump directly back into the tank and never actually leaving the tank. So the pressure up at the rail was ridiculously low. But the car would do okay idling. It would do okay, driving around town. It was just when you tried to go fast. So that lack of power could definitely be caused by a fuel pressure concern. Should be pretty obvious as soon as you put a gauge on and start it up. Surging. So let's talk about what surging actually is, and that's when the power you're getting out of the engine comes and goes. So you get a surge of power, and then a lack of power, and then power again, and then no power. A lot of times this is referred to as a lean surge, because that typically happens when your air-fuel mixture is excessively lean. Could fuel pressure problems cause your air-fuel mixture to be excessively lean? Of course they could, right, if your fuel pressure is too low. The next one, excessive fuel trim corrections. If your fuel pressure is low, then when the computer calculates injector on time to deliver fuel to the engine, and it opens the injectors for that amount of time, it's not going to be enough fuel because of the low pressure. So what's going to happen, the computer, going back to our fuel trim slides, the computer is going to see we're too lean. It's going to increase the fuel trim numbers so that extra fuel is added, and try to bring it back to the correct air-fuel ratio. So if we have low fuel pressure, we're going to see positive fuel trim numbers as it's adding fuel. If our fuel pressure is too high, we could have the opposite problem, right? We could have where every time the injectors open, they spray too much fuel, so we're too rich. And so we'll see negative fuel trim numbers as the computer tries to take fuel away to get it right. So the hard start one, this is the reason for that last test, the key off leak down test here. What's supposed to happen when you park a car is most or a lot of the pressure that's in the fuel rail is supposed to stay there so that the next time you go to start the car, there's fuel pressure available at the injectors instantaneously. If for some reason the pressure leaves that rail, and we'll talk about what those reasons could be, but if the pressure leaks out of that rail When you go to restart the car, it won't start until the fuel pump runs, pumps fuel up into that rail, and the pressure gets high enough to start the vehicle. So that could be a long crank time. Instead of starting instantly, it might crank for 3, 4, 5, 10 seconds while we fill up that fuel rail. So that's what we're testing for when we turn the key off and watch the leak down. So what you do is you pressurize the fuel rail to its full pressure by cycling the key several times, key on, engine off. Then you shut the key off and watch. On a good vehicle, the pressure loss should be 5 psi or less when you wait for a full minute, 60 seconds. If your gauge just keeps dropping throughout the 60 seconds, that indicates that there's a problem. And what could the problem be? Well, something's not sealing up. And one of those possibilities, the pump should have a one-way check valve that allows fuel to exit the pump towards the fuel rail, but not leak back. And then the other thing could be, any kind of a leak, any kind of a pressure leak. So fuel pressure regulator, an external leak, a leak in a line, injector O-rings, whatever. Well, not injector. Yeah, top injector O-rings could do it. So if you see this leak down, that could explain a hard start problem. And so you have to try to figure out where that leakage is. The way I've done it in the past is by clamping off return lines, clamp the line off from the pump so that fuel can't run backwards, and see if that fixes it. Yeah, that should about do it for this slide, I think. So we're going to do a fuel pressure test if we have no start, hard start, lack of power surging, excessive fuel trim corrections, and we don't come up with another reason for it. All right, vacuum. This goes back to pretty much the very beginning of the semester, where we talked about atmospheric pressure. We talked about what vacuum is. We talked about what's normal in an engine, what's abnormal. So, quick review, right? Vacuum is just any pressure less than atmospheric. In a typical engine at idle, normal vacuum readings are about 17 to 22 inches of mercury. So how do we see that? Well, you need a vacuum gauge, obviously. And that vacuum gauge needs to be plugged into a source of intake manifold vacuum. So it has to be below the throttle plate. In other words, it can't be outside the intake manifold. It has to be something direct intake manifold vacuum. That used to be really easy to do because a lot of things on the vehicle used to run on intake manifold vacuum. Now, as more and more devices become electrically controlled, it's getting harder and harder to find a vacuum port that you can plug a vacuum gauge onto. Typically still, the canister purge solenoid has a line going directly into the intake manifold. So on some vehicles, that's all you got. And that can be a pretty good sized line, so you're going to have some sort of an adapter for your vacuum gauge. So why would we be doing a vacuum test on a car? Well, again, if you look at the bottom, the red, right? Idle quality. Now maybe we have a rough idle. Idle speed. On some vehicles, particularly vehicles that use a speed density system, that's where it does not use a mass airflow sensor, but it uses manifold vacuum to determine fuel control. Creating a vacuum leak is no different than opening the throttle. It just makes the idle speed go up. On other vehicles, like if you take a carbureted vehicle and you create a vacuum leak, it's going to run very rough, nearly stall. And a fuel-injected vehicle that uses mass airflow, a vacuum leak, depending on how big it is, can just cause fuel trim problems, or if it's big enough, it can cause, very poor running. So I have a picture that I'll show you in a minute that can help kind of explain one thing that I ran into once. So we see misfires here. If there's a vacuum leak for one cylinder, that cylinder could misfire, right? Because it's way too lean. How could that happen? Well, one way is intake manifold leak at that cylinder. But another way, I'll show you that picture in a minute, something that I ran into 40 years ago, 35 years ago, that was actually diagnosed as a bad engine, and it was a vacuum leak. Another thing that might make you do a vacuum test, excessive fuel trim corrections, right? Surging, we talked about that with the fuel pressure, or lack of power. So we know that if our vacuum is just low, right? So it's supposed to be 17 to 22 at idle. If it's just low, most likely you have some sort of vacuum leak, right? So you're losing that vacuum somewhere else. Possibly late valve timing could do the same thing, right? It's affecting, if the valves are not opening and closing at the right time, it's affecting how well the engine breathes, which obviously is going to show up on a vacuum gauge. If you look at that second line, severe valve train problems, if you have a stuck valve, let's just think about this, an intake valve that doesn't close, right? Then every time that piston comes up, it's going to push air back out into the intake manifold. What are you going to see on the gauge? You're going to see a needle that bounces severely. I'm not talking just tiny little bounce, right? But every time that piston comes up, it's going to shove pressure back into the intake manifold. So you'll see a bouncing needle. That can identify valve train problems. On a normal running engine, when you do a snap acceleration, sudden acceleration, as that extra air flows into the intake manifold, the needle on the vacuum gauge will go almost to zero, almost to atmospheric. But then it will quickly catch up. In other words, as the engine speed increases, then the needle will go back into a vacuum, back nearer to that 17 to 22 inches of mercury, right? So it's normal to see a decrease in vacuum as you accelerate. But then as the engine speed catches up, the vacuum catches up too. If the vacuum never recovers, in other words, this is a classic symptom of a plugged exhaust, which could be plugged catalytic converter or anything else. What will happen is the faster you try to make that engine run, the worse it will breathe. The exhaust is blocked. It cannot get rid of the exhaust. It cannot take in new air. So what you'll see for that, you'll see an engine that has good vacuum at idle, potentially. But then as you raise the RPM, maybe you go to 2,000 RPM, 2,500 RPM, the vacuum just starts to go away. The needle starts going closer and closer to zero. And as that pressure backs up, a couple things will happen. One, the needle's moving closer to zero. And then secondly, the engine just won't accelerate, right? This is not the same kind of thing you get when you have a rev limiter on some cars. It's killing fuel injectors to keep the RPM down. And so that's very rough. It's the rev limiter. Other vehicles with an electronic throttle control, they just refuse to open the throttle plate in order to get the engine speed too high in park. They just won't do it. The computer's limiting the engine RPM because it's in control of the throttle plate. With a plugged exhaust, the real key is that vacuum gauge, the engine won't accelerate, and the vacuum gauge is hanging out at a very low number, very close to zero. It just can't get rid of the exhaust, so it can't take in more air. It has no vacuum. One way to verify a plugged exhaust is to physically disconnect it. So if you think your catalytic converter is plugged, disconnecting the exhaust in front of that catalytic converter should make the problem go away. Obviously, it'll be loud, but you'll have good vacuum and good acceleration again. It may be enough to simply remove an oxygen sensor, and that'll allow enough exhaust to escape out that oxygen sensor hole that it makes a big difference. So those are two things you can do to try to verify a plugged exhaust. Some of you, I'm not sure if you all got to see in lab before we got kicked out, I had a back pressure gauge, and we removed an oxygen sensor and screwed this gauge in its place. I know some of you saw it. I don't know, I can't remember if you all did. So that's another key that we can look at. We can verify the vacuum test results with this exhaust back pressure test. And what we saw in that is that exhaust back pressure on a normal engine is very, very low. It was less than a pound, really, under almost all conditions. We got it to go up a few pounds when we literally stuffed rags in the exhaust pipe. So exhaust back pressure is supposed to be pretty low. So here's a picture that I took in the shop of an intake manifold. This is a straight 6. This is on a Jeep. So you can see here the valve cover. Hopefully you can see the mouse moving right here. But what you see is this is the intake manifold here, straight 6, right? So here's the valve cover. Here's the fuel rail. Here's the fuel line coming in. And then each cylinder, right, here's the injector wire for cylinder 1, cylinder 2, cylinder 3 over here. And there's an intake runner for cylinder 1. There's an intake runner for cylinder 2. There's an intake runner for cylinder 3. And notice what's right here is a little vacuum cap. There's a little vacuum nipple that is unused on this vehicle. And so it's just blocked off with a little rubber cap. The experience I had, see if I can, yeah, it's a little better view of it. So the experience I had back years ago, a customer brought a vehicle into the shop, and the customer's concern was they had been to a shop called Auto-Tune. So this was before Auto-Tune had anything to do with your voice or singing or anything. Auto-Tune was a chain of tune-up shops. You'd bring your car in, and for a set fee, they would do plugs, and back then you did distributor cap and rotor and points and whatever was necessary for whatever they called a tune-up, maybe air filter. And then they hooked it up to a big fancy diagnostic machine. So one of the tests the diagnostic machine did was a cylinder power balance, right? So this is something you should be familiar with now, right? Cylinder power balance, and it indicated that one of the cylinders was weak, and so they told the customer, "You need an engine. You've got a bad cylinder." So this is not the kind of work they did at Auto-Tune. Auto-Tune was just a tune-up shop. So they handed him the fancy computer printout, and in he came. Now, never mind that, rather than bringing the car to us for a tune-up, he tried to save money by bringing it somewhere else. Okay, whatever, we asked him, before we put an engine in your car, do you mind if we just look at it ourselves? And he said, no, go ahead. So almost immediately what we noticed, that there was a setup similar to this. It was a straight 6, and there was a vacuum hose So it wasn't capped off. It was a vacuum hose that went to somewhere, but it was on one of the intake runners. So, you know, think about it. If this vacuum cap cracked or were missing, I guess on this engine, it would probably affect cylinders 1 and 2. It would have no effect really over here on cylinder 3, right? Because the air's coming in, you know, through the throttle body over here and coming in. But as the air flows through to cylinders 1 and 2, and this extra air is being drawn in, those two cylinders are going to be exceptionally lean, and they're going to misfire. So on this one years ago, right, this was not out here. It was more like, say, here in this area right here. So it was only affecting just one cylinder. That cylinder was misfiring. And so this shop had diagnosed it as a weak cylinder when the repair was, you know, you can imagine back in the 1980s, early 1980s, what it cost to repair a broken vacuum hose. It was not a lot of money. Okay. Stop sharing this. Okay. So that's just a little story I like to tell. Don't let your diagnostic equipment tell you what to do and, you know, override your actual brains, right? So all it took on that vehicle to override this fancy computer's diagnostic that it needed a new engine, all it took was a quick visual inspection. I want to say the entire diagnosis in our shop took a minute and a half, maybe. And after replacing that cheap piece of vacuum hose, the misfire was magically gone and the engine ran fine. So let me stop this and let's go back to our blackboard here, or back to our slides. Here we go. Yeah. So vacuum test can tell us a lot of things, right? This is why I say, though, it can cause idle quality problems, right? If you're too lean at idle speed problems, too lean could cause it to idle poorly, and, you know, idle quality and idle speed kind of go together a lot of times, right? But it could idle too fast because it's getting air in, just as it would through the throttle plate being open. And the computer sees the decrease in vacuum, so it adds fuel. That's not on a mass airflow, that's just on a speed density car. Misfires, we just talked about that. Excessive fuel trim corrections, okay, you know, if we're too lean because of a vacuum leak, we're gonna get fuel trim corrections. Surging, same thing, lean surge. And then lack of power, we talked about possibly plugged exhaust. So a vacuum test can help us diagnose that. Okay, let's move on. Here's something that we've been through in the shop. So this shouldn't be new to you, but just to make sure that everybody's on the same page and everybody understands, you know, exactly what we're doing here, right? So a compression test, and let me skip to the bottom of the next slide, right? Why would we do one? And, you know, misfires, hard start, no start, or lack of power. So depending on what symptom we're trying to diagnose, we're looking for something different out of a compression test. If we have misfires, we are probably looking for one cylinder that is different than the rest. If we have hard start, no start, or lack of power, we may be looking for some sort of a problem that is connected to all of the cylinders. So think about what kind of problem that could be. So how do we do the compression test? Well, obviously we need a compression tester. We want the engine ideally to be warm. but not hot. Why? So why do we want it warm instead of cold? Well, when engines are manufactured, all of the tolerances, clearances, things like that are all specified for an engine at operating temperature. So when an engine is at operating temperature, all of the clearances are where they're supposed to be. When the engine's cold, those clearances may be different. So the engine is designed to run most effectively, most efficiently at operating temperature, because that's where it's going to spend most of its time. The reason we don't want it hot is there's a little bit of a problem with removing spark plugs. Didn't used to be that big of a problem when cylinder heads were cast iron, but now that most cylinder heads are aluminum and spark plug shells are still steel, these two materials have different expansion rates, and because of the different rates of expansion on a really hot engine, the spark plugs can get sort of locked in to the spark plug ports, spark plug holes, to the point where if you force them out when that engine's really hot, you may take aluminum with you. You might take the threads right out of the cylinder head. That's not something you want to do, because that can turn a diagnostic test into a major repair. You may need to remove the cylinder head in order to fix that. That's not something you want to get into. Now, can you always do a compression test on a warm engine? Well, no, because if you look again at the symptoms, one of the symptoms could be no start, right? And on a no start, how do you warm up the engine? You don't, right? So you're doing it on a stone cold engine, probably 60 or 70 degrees, whatever temperature that wherever the vehicle's been sitting. We want the throttle wide open. Now, this used to be a really easy thing to do, but unfortunately, it's not necessarily a really easy thing to do anymore. When throttles were operated by cables or linkage, we could just open the throttle with our hands while this test was going on, or just step on the accelerator pedal while the test is going on. Now with electronic throttle bodies, on a lot of vehicles, you have to use a scan tool and put the vehicle in compression test mode. And what compression test mode does for you, it will open the throttle, it will disable the ignition and the fuel injectors. So it's actually kind of convenient, but you have to know about it. In a minute, we'll go on all data and we'll look up for a particular vehicle the compression test procedure, and I think you'll see that it's one that you use a scan tool for. Now, in an older vehicle, you don't have that option. I used to tell my students that opening the throttle as opposed to closed throttle didn't make that much difference on a compression test. But I always pay attention to, and I always make the students do it both ways. See what happens if you don't open the throttle. See what happens if you do open the throttle. And I think it might have been a Honda this semester where there was a really significant difference in the compression pressure we got when we didn't open the throttle. When we didn't open the throttle, the numbers were way lower than they were with the throttle wide open. So, that's kind of convinced me that regardless of the vehicle, I want to have the throttle wide open during a compression test. We remove all of the spark plugs. I'm not going to say that I've never done just a single cylinder. If I knew that a particular cylinder was misfiring and I just wanted a quick check to see if the problem was compression related, I've done it. Just pop a plug out, screw the gauge in, crank it over, see if I'm at zero on that cylinder or close to it. But for the most part, if we're doing a full-on compression test, removing all of the spark plugs will make it real easy for the starter to crank the engine over. It will put the cranking speed where it belongs for the compression test, where with the min, it'll be cranking slower than it should. And it's much easier on the battery, much easier on the starter, on the battery, everything, you know. So pull all the plugs, connect the battery charger. You're going to be operating the starter quite a bit during this test, so that is going to have a tendency to bring the battery level down. Install the compression tester and then crank the engine. So one cylinder at a time, we're going to put the tester in, crank the engine. The important thing here, right, is to be consistent. Do every cylinder the same way. I'd like to say that I can give you an exact number of how many engine rotations or how many compression strokes you should do on each cylinder, but I have seen some that say 5 compression strokes. I've seen some, and I'm talking about factory directions, right? Some that say at least 5 compression strokes. And I have seen some that say until the gauge stops going up, so getting maximum compression. And I guess, you know, this really is a function of how they came up with the specification they're giving you. What we want to do is we want to do each cylinder twice and then average the 2 readings you get. Compare those readings to specifications and compare those, you know, every cylinder to the other cylinders. And the lowest cylinder should have at least 75% of what the highest cylinder has. How do we interpret the results? Well, if one cylinder is low, then that cylinder has a problem. Got a valve that's not sealing, rings that are bad, damage to the piston, blown head gasket, I don't know. If 2 cylinders that are next to each other are low, they are probably leaking into each other. So where the cylinders come close together, blown past the head gasket from one cylinder into the next. If all the cylinders are low, or all the cylinders on a bank with overhead cams are low, it probably indicates a problem with valve timing. Now, we had a really obvious one in the shop this semester, that Subaru, with all the valves bent, there was no compression in any cylinder. So that is a systemic problem, if you will. It's not, you know, not just to one cylinder. But what caused the valves all to be bent? It started out with a valve timing problem, right? A broken timing valve. See if I can pause things a minute here. Okay, it took me a minute to get this up on the screen for you. Make sure that I'm where I want to be here. Come on. All right, we are. Okay, so I have brought up a what a pain. Brought up on all data this 2015 GMC Sierra that we were talking about, or that I used in the lab, right? And under powertrain management, I just actually searched, I think, let's see, I'm just going to search compression test. Too many S's. Engine compression test. So, okay, it's under powertrain management, tune-up and engine performance checks. So, we need a spark plug port adapter, right, for the compression tester. But here's the part that I was telling you about. All right, they want you to run the engine until it reaches normal operating temperature. You might want to connect a battery charger during the test. remove the spark plugs, and connect the scan tool and select compression test. So what it does then is it disables the fuel pump, fuel injectors, and spark. The throttle body is open to wide open throttle position. Also, the scan tool will automatically control the cranking procedure on some vehicles. If cranking control is not available, use a remote start switch in place of the starter relay to control cranking. So that's where you hook a switch right to the starter motor. And then they have you crank the engine, and it says 4 compression strokes. So like I was telling you, some vehicles say 4, say 5. Some say crank it to get the maximum reading, you know. And then they give you a very low ball 100 psi as a minimum. And here they're giving you even a wider range here. The lowest can be as low as 70% of the highest reading. I don't really like that, and I'll tell you why. 70%, if I had a car and the lowest reading was 71% of the highest, I really wouldn't expect that vehicle to run that smoothly. But that's their standard. That's what they give you. Remember, you're doing this test because you're trying to diagnose something. So you're already looking for either a misfire, a hard start, no start, lack of power. If I have a misfire and I find one cylinder is only, the lowest cylinder is only 70% of the highest, and that's the cylinder that's giving me a misfire, I'm going to call it a compression problem, definitely, So in general, and we look at all these tests that are available, in general, let me just say, you're going to do these tests from easiest to most difficult. On a lot of vehicles, compression test is going to be near the last thing that you do, right? Because it's typically pretty easy to check for spark. A lot of times it's pretty easy to check fuel. So you may never get to the compression test when you've already identified the cause of the misfire. But if you're here, then you've probably eliminated spark and you may have eliminated fuel already. So you're looking for something, and you know what you're looking for. If it's a hard start or a no start, you're looking for low compression kind of across the board. Same with lack of power. If you're looking for a misfire, then you're thinking that compression is low on one cylinder possibly, and that's what you're looking for. So let me stop sharing this. Let's give me a minute here. And don't mind me. Start the video a little bit here. Okay. So I think that's about all the talking I can do for this week. Hopefully you stuck with me and listened to the whole thing. We're getting near the end of the semester, so obviously, the next test you take is going to be the final, and it's going to incorporate everything that was on the last test, plus the stuff we're talking about right now. And a lot of the stuff we're talking about right now is not necessarily new to you. We talked about compression tests back in the first couple weeks of the semester. We didn't talk about it so much in the lecture, though. We talked about it out in the shop. So there will be questions on it. Questions, like what does it mean if 2 cylinders next to each other are low? What does it mean if all the cylinders are low? Technician A says that the engine should be, warmed up. Technician B says you have to let the engine cool for 8 hours for a compression test. Who's correct? Things like that, just to make sure that you understand what it is we're trying to do here. So that's it for this week, and I'll be working on a lab. Hopefully in the next couple of days, the lab should come out for those of you that are in the lab. And it'll be similar to the last one I did where it's a video. It's getting more difficult to come up with things to do with only a scan tool and a vehicle that I don't want to take apart. So but I'll come up with something, and it'll be another assignment to watch the lab and do the lab report. For this, just watch this, pay attention. You'll always have these to look back at before the final comes along, but that'll be the last week of the semester that we do that. See you next week.